Okay, now we are on the last page, and we have a binomial because it has two terms times a trinomial. So we're going to go ahead and we're going to start by distributing b through. So b times b squared is b cubed. B times 5b is plus 5b squared. And b times positive 2 is plus 2b. Then we're going to distribute our positive 3. 3 times b squared is plus 3b squared. 3 times 5b is plus 15b. And 3 times 2 is plus 6. Combine your like terms and put it in standard form. There's only one cube, so I'm going to go ahead and write it first. B cubed. Then I have positive 5b squared plus 3b squared is positive 8b squared. Positive 2b plus 15b is plus 17b, and then plus 6. Number 25, you can do two different ways. The first way is you can realize that they are the same, but it fits the form a plus b times a minus b, which is just a squared minus b squared. Or you can distribute. So if you do it by distribution, you'd start by doing 8. X times x is x squared. X times positive 9 is plus 9x. Negative 9 times x is minus 9x. And negative 9 times positive 9 is minus 81. So your middle two terms cancel, and you're left with x squared minus 81. You could have also thought about this by a plus b and a minus b, where a is your first term, x, and b is your second term, 9. So you'd have x squared minus 9 squared, which is also x squared minus 81. Either way is perfectly fine. Number 26, you can follow the special trick, or you can go ahead and write it twice. 4y plus 5 times 4y plus 5, because it's a binomial squared. 4y times 4y is 16y squared. 4y times 5 is plus 20y. Positive 5 times 4 is plus 20y. Positive 5 times positive 5 is plus 25. So when you combine your like terms, you get 16y squared plus 40y plus 25. That's a 40. Number 27. I really like 27. It's pretty interesting. If you have x minus blank and x plus blank, you get x squared minus 121. Essentially, this follows the rule a plus b times a minus b is a squared minus 121. So what would have to go in there for this to be true? So if you thought about it, you would have, if you thought about this blank as just a blank space, if you were doing it by distribution, you have x times x is x squared. X times your blank would be plus blank x. Negative blank times x is minus that blank times x. And then if you did a negative times a positive, you have negative. Whatever is inside that blank would have to be squared. Notice if you have positive something and minus something, it would cancel. So you'd be left with x squared minus something squared. Well, what squared gives you 121? Oh, 11 does, because x squared, 11 squared is 121, minus 121. If you plugged 11 into both the blanks, you'd have plus 11x minus 11x and 11 there. So what would go in both blanks? 11. The way that you can find that, the square root of 121. If it were 49, it would be 7. If it were 25, it would be 5. Number 28, if you have x plus 3 quantity cubed, remember you have to write this 3 times. X plus 3 times x plus 3 times x plus 3. You have to write that binomial 3 times because it's cubed. You multiply it 3 times. So you multiply the first two binomials, you're going to get an answer, and then multiply it by your last binomial. So x times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. 3 times 3 is plus 9. I would simplify this first and do x squared plus 6x plus 9 times x plus 3. I'm going to go ahead and I'm going to distribute backwards. squared is x cubed. X times 6x is plus 6x squared. X times 9 is plus 9x. I can do this because of the commutative property that says the order doesn't matter that you multiply. 3 times x squared is plus 3x squared. 3 times 6x is plus 18x. And 3 times 9 is plus 27. Combine your like terms. There's only one x cubed. Positive 6x squared plus 3x squared is plus 9x squared. 9x plus 18x is plus 27x. And then last but not least, your constant of plus 27. So you get x cubed plus 9x squared plus 27x plus 27 as your final answer.